Okay, so this is problem 3, cache access streams, and we're given these 5 accesses right here with store and load words and specific values. We're given some information here, and we want to find, compare and contrast these 3 types of caches: direct map, two-way set associative, fully associative. And so I've drawn out this helpful table here that will help us solve this problem. And so let's first start with direct map cache, and we want to find out the offset bits first and then the index bits so that we can determine the set. So remember, offset bits is log base 2 of the block size, so log base 2 of 8 is 3 offset bits. Index bits is log base 2 of 4. So log base 2 of 4 is 2 index. And then we have enough information to find out the sets now for a direct map cache. So this is all 0, so our index is definitely 0 bits. And for this one, load word 0x10, I can just write it out, and this is definitely something you guys can do too for each one. So we're going to get rid of these offset bits, and these 2 will be our index bits. So this is 2, and you can use the same methodology for these 3, but I'll just tell you which set they belong to here. And now we can go ahead and go through our access stream. So first we're doing a store word. We're storing this value, and our cache is empty, so we miss when we store that, and we set our dirty bit to 1 because it is a store word. A 0x00 is dirty. Next, we are loading in this value. It's a miss, it's not already there, and we're just loading it into set 2. We're storing another value, 0x20, it's not already there. And so when we're storing this value, remember with the direct map cache, we have a bunch of sets but only one way to put them in. And if 2 values map to the same set, as in this case right here, then we have to evict the first one. So I'm gonna say we evict 0x00 in order to put 0x20 there. And once we evict 0x00, then we have to write it back because this is a write back cache, right? And so I'm gonna indicate WB here for write back. We're writing back that value there. And so dirty bit is 1 because we're just storing 0x20, but we have to evict that to do that. And then next we're loading it back in, and that is a miss because we just now evicted it, so it's not there anymore. And in order to load it in, we have to evict the one we just put in there, so 0x20. So I'll write that in, evict 0x20, parentheses write back. I'll box that up, and since it's just a load, 0x00 is clean. Finally, we load in 0x20, so that is a miss because we just evicted it. And so now we have to evict 0x00 again. Since it's just the load, we don't have to mark it as dirty. And we don't need to write back either because the previous value, 0x00, was clean already. So for this, our final result, which I'll write in this color, is 0 hits. We haven't hit even once, and I've indicated where we wrote back, so that is 2 write backs. So that answers that question. Next, we are looking at two-way set associative, and so we have to calculate our index bits to figure out what set we're in. And so since there's 2 sets, we have 4 lines, so we do 4 divided by 2, which is 2, we have 2 ways, so we have 2 sets here. So log base 2 of 2 sets is 1 index bit. And the offset bits carry because our block size doesn't change. So I'll write here still 3 offset. So that changes where we put our values for our set. So it's always going to be 0 for this one because this is just 0x0 0. And then let's just look at this one, 0 0 0 0 1 0 0 0. And so we have 3 offset, and this one is going to be our set, so that's 0. And you guys can go through and see that since the last byte is always 0, this value is always going to be 0. Everything maps to set 0. And you'll see how that plays out later. So let's go ahead and store word 0x00 first. It's not there, so we miss. We're storing word, so dirty bit is 1. And I'm going to go ahead and in this column, I'm going to indicate our most recently used to least recently used. So we start out with just having 0x00, and that's going to be our most recently used. For loading this in, it's a miss. It's just a load word, and now we realize that set 0 is full. There's only 2 ways, right? So we have our MRU is on the left hand side, LRU goes all the way to the right hand side. So we most recently loaded in 0x10 and least recently stored in 0x00. So that's what our little array looks like there. We store word 0x20, that is a miss. And our cache is full, so we have to evict our least recently used, which is right there. And since that's dirty, we have to do a write back. So I'm going to indicate WB here for write back. And then we load in 0x20. And that is dirty because it's a store word. Sorry, we store in that value. And so we most recently use that, and then we just scooch everything down, 0x10. And there's only 2 ways, so that's all we can fit. That's why we had to evict this. Another load word, in this 0x00, we had just evicted it, so we actually miss. And we have to evict 0x10, because that's our LRU. And this is just a load word, so no dirty bit. And now, we most recently used 00, least recently used 0x20. Finally, we load word 0x20. So let's look at our little cache right here, and we see that our MRU LRU array, we see that it's in there. So it is a hit. It is a hit. And we are going to just a load word. Now, since we just loaded that in, we're just going to switch these 2 up because this is now our most recently used. So it's nice and helpful to keep track of a little array like this. And so right now, our final answer is that we had 1 hit and 1 write back for 2 ways at associative. Last problem is fully associative. So we have 4 ways available right here. So there's no need to calculate a set here. So we're just going to skip that and go in with our hit and miss. So I'm going to go ahead and for these first 3, they're the first ones in there, so we're gonna miss for all of them. And because we're storing word here, we have a dirty and a dirty, marking those as dirty. And we're gonna go ahead and list our cache here, 0, 0. I'm going through this a little bit quicker since we already did this. 0x10, 0x00. And then for this one right here, I'm going to erase this. We have 0x20, 0x10, and we don't need to evict anything this time. We can just keep on adding. Okay, so now we're loading this back in. It's already there, so we actually hit. A is still here, and we don't do anything. And then we have, now we just promote it to most recently used. And then we scoot everything down. And then the last one is that we hit. It's already there. And then now we put this at the top. Okay. So our final result is 2 hits, 0 writebacks. And the first 3 misses at the start were compulsory. And so, remember, at the end, these 2 are still dirty at the end because they're written by the 2 store word instructions, and the cache hasn't performed any writebacks. So the only way that we are going to perform a writeback is when we evict something from the cache. Then we need to think, okay, is the value there? Do we need to write it all the way back to a lower level of memory?